Question: how fast is the light from your monitor to your eyes traveling? How long does it take the light from the sun to reach us? What is the speed of light? Tonight we're going to answer that question with some marshmallows and a microwave. Oh yeah. To help us with our experiment, we're going to use Mr. Microwave. Most microwaves have spinning cooking trays in them to help cook the food more evenly. We don't want our food to move, and we don't want it to cook evenly. So what we're going to do is take our cooking tray, flip it upside down, so it doesn't move. Here we have our plate of marshmallows, covered with one layer of marshmallows, the whole face of it. We're going to put that in there. And we're going to cook this for about 30 seconds. You can start to see the marshmallows rise at the hot spots and stay low at the cold spots. So we have hot spots about here and here. Now it's kind of going back in the microwave real fast. It's kind of hard to tell the distance. These things are being really stubborn. There we go. So I got my ruler here. I'm going to quickly measure this to be about 12 centimeters from toothpick to toothpick. So we have our unit of length, 12 centimeters. This is from the hot point to the hot point of the marshmallows, or the amplitude to the amplitude. There's a fancy word for it. It's called wavelength. Non-nerd basically means how far it is from peak to peak. So that's our length, 12 centimeters. What else do we need to find the speed of light? This microwave is using waves to cook your food. These waves are the same thing as light waves. They're just invisible to us. So how do we find the speed of this wave, or the speed of light? Another way to ask that, to help us out here, think of the speed of a car. Your car travels at miles per hour. 30, 60 miles per hour, 120 if you're in a Corvette. So we have miles per hour. Miles, unit of distance or length, per hour, a unit of time, distance per time. So we have our length, our distance, 12 centimeters. What kind of time do we need to get speed, or the speed of light? On the back of every microwave, you have a label for output frequency. This microwave has an output frequency of 2,450 megahertz. What's a hertz? Hertz is how frequent something happens every second. So 1 hertz is once per second, like my head bob. 1 miss, 2 miss, 3 miss. I have a head bob of 1 hertz. I can do 2 hertz, or I can do a lot of hertz. Slow down at the end there. My head hurts. That's hertz, how frequent something happens every second, or the frequency. So this microwave, 2,450 megahertz, or 2,450,000,000 hertz. 2 billion times every second is how fast this microwave puts out light waves. That's really fast. The speed of light's fast, so that makes sense. So we have our length, put it together with our frequency, we'll get the speed, our speed of light, which is 290 million meters per second, or 650 million miles per hour. There's no car or Corvette, not even jets, can get anywhere near that speed. That's 180,000 miles every second. Do you know how fast you could go around the Earth if you were traveling 180,000 miles per second? You can go around the Earth 7 times in 1 second if you were traveling that fast. Had a little bug traveling the speed of light, it would go past you and around the entire Earth and past you again 7 times in 1 second. That's really fast. I hope you enjoyed our experiment you could do at home, presented by Oxford Learning Source. This is the place where I work. Oxford Learning Source is an internationally accredited school for K through 12. This summer we are offering classes that students can take to make up credit. Classes from English, writing, to financial lit, math, and even chemistry. We also offer ACT prep for those who want to get a jump start on the ACTs. We have a special program this summer, Oxford's Discovery Camp, for grades 3 to 7. It is 3 hours, Monday to Thursday, for 2 weeks, starting this June 30th. This summer camp is to help kids understand math and how they can use it to understand the world around them. In the first hours, we start with mental math exercises and arithmetic practice. This helps build confidence in dealing with numbers and can help overcome any math anxiety your child might have. The next 2 hours is demos and experiments that help kids understand science and the math that relates to them. I love teaching science, and I would like to thank Oxford and you for giving me the opportunity to spark some curiosity. At least I hope I did. For more information, look at the description below, and I hope to see you this summer.